Alrighty guys, so we're gonna continue with 7.5. So after this try problem, we're evaluating the functions involving double angles. So we're using the following to find sine 2 theta, cosine 2 theta, and tangent 2 theta. So first thing I want you to realize is this right here. It says we're in between 3 pi over 2 and 2 pi. So if this is 3 pi over 2 and this is 2 pi, that means we're in quadrant 4. If we're in quadrant 4, then sine is negative, cosine is obviously positive because it's positive, and tangent is negative. So remember, cosine is x over r. Sine is y over r, and tangent is y over x. So sine of just regular theta is y over r, which is going to be 5, 12, 13 is one of our special triples. So 12 would be y, so 12 over 13, except it's negative. And then tangent theta is going to be negative 12 over 5, since it's y over x. Okay. Now, the thing is we want sine 2 theta, cosine 2 theta, and tangent 2 theta. So we have to go up and remember all of our formulas that we just learned about. I went too far up here. Where did they go? Here. So we know sine 2 theta, cosine 2 theta, we could use any of those, and then tangent 2 theta, which we haven't used yet. So you guys can flip back and forth. I have to go back down. For sine 2 theta, that one's pretty easy. That one's 2 sine theta, cosine theta. So 2 times sine theta, which is negative 12 over 13, times cosine theta, which is 5 over 13, which you guys can do the math. It ends up being negative 120 over 169. And if you guys need me to do that math in the Zoom meeting on Friday, we can. Cosine 2 theta, I'm going to use the 2 cosine squared theta minus 1. So that is 2 times 5 over 13 squared minus 1, which is 2 times 25 over 169 minus 1, which is negative 119 over 169. Okay? And then for tangent 2 theta, I'm using a different stylus, so it's not working out very well. We have 2 times tangent theta over 1 minus tangent squared theta. So we have 2 times negative 12 over 5 over 1 minus negative 12 over 5 squared. And then once we simplify that whole thing is 120 over 119. Okay, I know you guys can do fractions. If you need me to show you those over Zoom or explain those, you guys maybe need to work those out. That's fine. do that, but just to save time, I'm not going to. I am getting my other stylus though, because I don't like this one. Okay, so let's try another. Maybe pause me and try this one on your own. So, about the same thing, except let's notice which quadrant we're in. This is quadrant 1, so luckily we don't have to worry about negatives because everything's positive in quadrant 1. Now, 3/5, that tells us it's 3, 4, 5, because 3, 4, 5 is a special triangle. So sine is y over r, so that tells us that x is going to be 4. So cosine theta is going to be 4 over 5. And tangent theta is going to be 3 over 4. So the work is going to look a lot, the formulas we're going to use are going to look identical to the ones we used in the previous example. So sine 2 theta is equal to 2 sine theta cosine theta. So 2 times sine theta, which is 3/5, times cosine theta, which is 4/5, which gives us 24/25. And then we've got cosine 2 theta, which is 2 cosine squared theta minus 1. Which is 2 times 4/5 squared minus 1, which would be 2 times 16/25 minus 1, which would eventually give us 7/25. And then tangent 2 theta, which your tangent is going to be your algebraically hardest one because it's a fraction. Remember, reference these in your notes. So 2 times 3/4 over 1 minus 3/4 squared. Simplified, that would be 3/2 over 7/16. And you would get 24 over 7. So there you go. I know I went kind of fast, guys, but after you plug into your formulas and once you get these pieces right here and plug into your formulas, it's really just simplifying fractions. So we're going to actually skip this. We're going to skip this. We're going to skip this. So the next time you see me in the video, we're gonna be jumping down here to using half angle formulas. I know this video is pretty short, but they upload a lot faster. So I'll actually probably get one uploaded here pretty soon. So I'll see you guys soon.